a great panel discussion this morning discussing new materials in the 3D printing space. Olivia from Imperial College London will be moderating the panel, joined by Elham from Hitachi Energy, Candice from the University of Sheffield, and Elizabeth from University of Warwick. So I'll hand over to Olivia. If we could just go around and just give a brief introduction about yourselves, and then we'll continue with the questions.
Absolutely. Hi, welcome everybody, and thanks, Laura, for the introduction. I hope you can all hear me well. And yeah, so my name is Olivia Calasika. I actually just submitted my PhD just on the weekend. So thank you so much. I'm currently developing new materials for additive manufacturing, in specific VAT polymerization. And if I need to be even more specific, I work with soft materials like hydrogels, which are these basically water-based materials. I just want to make a general introduction. I will try and look at the general chat as well as the Q&A for all the participants. So if you have any questions during the panel discussion, I will be trying to look at both of them. And now I'll give the the floor to Elham. Perhaps you can introduce yourself.
Okay, thank you, Olivia. Hi to everyone. I'm Elham. I'm a metal additive manufacturing scientist in a Hitachi Energy company. Actually, I'm working in one of the global research center, which is located in Krakow, Poland. Actually, I've started my PhD in mechanical engineering in 2016, and my field of study was metal additive manufacturing again, but in developing a novel method for printing aluminum alloys in a semi-solid state. Okay.
Great.
Yeah.
So maybe Candice, if you could go next.
Yep. Hi, I'm Candice from University of Sheffield. I'm an academic there, so I guess part of my job is on the teaching side. On the research side, I'm really interested in powdered polymer additive manufacturing, so in particular laser sintering and high-speed sintering, and really looking at material development from a kind of a very scientific end of what happens in the process to the industrial end. So how do we get materials out there that are useful for the people who want to use them?
Great. And Elizabeth, perhaps if you could finish up.
Yeah, good morning, everyone. Elizabeth Bishop. I'm just finishing up my PhD at the University of Warwick. So I'm in the writing stage. So yeah, getting there. And I'm also a teaching fellow at Warwick as well. So I do a bit of teaching as well. My PhD is in large scale additive manufacturing. So looking at the techniques and technologies for polymer, so thermoplastic, so FFF, but on a larger scale. So sort of looking at a meter squared cubed sort of size area in terms of the scales there.
Wow, that's impressive. So if I have to wrap up a bit, I think it's great to have such diversity today, because I think we can touch base on different materials as well as different printing technologies. And yeah, maybe to start off, I can ask you just a question. I mean, I think maybe we can go in round and we see where the discussion leads on to. But what do you think are the current challenges additive manufacturing faces when adopting new materials? Maybe Elham, you can start, since you can also give the perspective of industry, perhaps, because I'm sure it's quite different than academia.
Yeah. Actually, I want to speak with this challenging of new material about my PhD thesis, because it was too relevant. In my PhD thesis, we want to develop a new aluminum filament with a refined microstructure and really good mechanical properties. So we needed to test this filament with the additive manufacturing system. As you know, new material comes with new technology and new requirements. So after a lot of searches, I understand that there are two groups of additive manufacturing for metal. One of them has high power sources like wire and arc additive manufacturing that completely melting the metal filament. At the other hand, we have extrusion-based additive manufacturing for metal, that they use resin and metal powders to make the metal filament, and then they print this filament in the low temperature. So what I need was a filament-based additive manufacturing more than 600 degrees Celsius. I don't want to use metal powders. I didn't want to use resin to mix it with powder. So I didn't find exactly a printer match with this new material. So I should develop a new printer, a new technology to print this material. So it's the challenging that I'm facing with. So I think this is the reason that every new material that we added to additive manufacturing, we should add another new technology, another requirements that is compatible with it.
Absolutely. I think I can also, I can jump on that. I think I had similar issues when I started my PhD, when I was trying to decide what printer to go for. I thought about developing my own, and I think I did a hybrid. So I think it's, very nice to listen to similar stories.
Yeah.
Elizabeth, perhaps you can share your answer as well.
So I think for me and for sort of the work that we've been looking into, particularly when you're looking at large scale and kind of if it goes wrong, there's quite a lot of waste there. So for us, it's kind of quickly establishing like the right settings and the process parameters. So like what settings are you going to use for a new material? And part of that work is kind of linked into part of my PhD there, and kind of trying to develop almost like smarter 3D printers that can themselves kind of work out what those process parameters are kind of within a sort of band, so that you're not kind of shooting in the dark and completely out there, that the printer can kind of try and adjust to those new materials and kind of get a close enough setting to kind of be a good starting point to go from. So yeah, a lot of my work's been in trying to develop kind of and improve that using thermal monitoring and kind of smart printers to improve that.
Wow, that's very much needed as well. I guess you use, is it mainly, would you say that it's a lot of software as well, or is it actually on the printer? So let's say adding, sensors and so on and so forth.
Yeah, kind of a combination of both. So on a software side, kind of interacting with the control boards of the printers to sort of like on the fly kind of actively change things rather than just sort of taking your G code and that's it. And then obviously you've got to have all the sensors and to be able to make those decisions, to be able to make those changes.
Yeah, makes sense. Nice. And Candice?
I was just smiling then because I really relate to what Elizabeth just said about trying all the parameters and trying to get where you need to be. I guess for me, it's a couple of things. One is understanding how the parts will behave long term. So we tend to have a really good idea of straight out of the machine, the part will behave like this, that's great. But in 6 months' time or 2 years' time or whatever the lifetime of a product made with it is it still going to be the same? So there's a lot to do with that and the kind of qualification of materials and convincing people that, yes, you're okay to use this. And I guess the other thing, and perhaps partly tied into that, is educating material manufacturers. So there's a load of polymer material manufacturers out there who know everything about their materials, how they behave, they know how to modify them, but what they don't know is how to modify them in the right way for our processes. So there's something there about kind of helping them to understand how materials behave in a process so that they can then modify their materials to be more suitable, behave better, last more long term, and so on. So I think that working with industry and trying to kind of get those points across is really important for us.
Yeah. I mean, I think you all gave different answers. They're all equally important. And there's so many questions that come up in my mind right now, and I'll just try to sum this up, and if you were to, let's say you had all the possible network in your hands, and you could, basically just reach out to anywhere out there, what would be the first thing you do to, let's say you have a new material you want to develop, what kind of support would you go out and ask for? Is there something that like you feel is missing that you would like to ask support for, or something that you believe that is still let's say, maybe for instance, I did develop new materials. I found myself struggling with the ASTM standards. Sometimes you want to kind of harmonize a bit the processes, and maybe they don't exist yet for that type of material. So for instance, for me, the answer would be, collaborating more, with really the high level people out there to develop standards, for materials. But I'm just asking the questions now to you. Whoever wants to go first. I think Elizabeth, maybe you're ready. I see, ready to pose your mic there.
I was just really resonating with that on the standards and things. You often get sort of like, when he's trying to submit papers, they're like, have you done any tensile testing on this? And it's like, well, you can, but it's not really relevant to what I've printed or how I printed something. So yeah, I kind of feel like what you're saying with that, with there not being kind of the right standards to test things in AM, because it's so different from kind of your homogeneous materials and things. But yeah, that was kind of what I was just going with that.
Yeah. Don't know if you have, if Elham or Candice, if you have anything you'd like to add on that. I'm pretty sure there are tons, perhaps.
Yeah, so I agree with you both. I think standards are really, really, really important. Another thing that's important for us, and I think when we're trying to screen new materials, so there's thousands upon thousands. I have no idea the exact number of polymer grades out there, and some of those will work brilliantly in our processes. Some of them will work well if we can tweak them a bit, and some of them will be utterly rubbish and will never work in that situation. And so for me, it's the kind of it may be the machine learning people, the people who have this experience in modeling complex processes, but then going through lots and lots of iterations of kind of virtual testing to get to the point where we've got at least a selection of materials that we think should be good. And I think if we could remove some of that kind of trial and error and repeats of experimentation of all the new materials, then I think we could get to these new materials that work well much more quickly. So it's bringing in those kind of computer modeling people together with our expertise on the material side and saying, actually, what can we do there? And I think if we can get those models really good, we could make incredible advances in finding new materials much more quickly.
I really agree with Candice, because I have this experience and this comparison with industrial and academy, because when I'm working in a team in my company, every project is really good, because every professions come gather together. When we have the projects related to additive manufacturing, we have an expert in simulation, we have modeling experts, we have material experts, especially for each kind of material, ceramics, polymers, metals. But in academia is really different. You are in your own. You don't have any supports. You should simulate by yourself. You are model by yourself. You have built the system by yourself, and it's really hard and time consuming. And you have to do something that is not really worth to spend time, but you have to do that.
Yeah, very, very, very good point, Elham. Absolutely, again, resonate with that. And I think, if I can add on what Candice said as well, one thing I believe is having the simulations and the materials as well. But then I believe that due to the manufacturing process, as well as the way that we can design the materials, we can, the materials property may change just because of the manufacturing, right? So I'm not sure then the simulation, where does it stop, because should it go then also while it's printing, because then you can change things there as well. So it becomes a very, very complex issue that, that could be a topic on its own. So perhaps better not to diverge too much. But, that's, I think, we said something very important there, that exact a bit more of the let's say, including the simulation as well as all the computational models would be great to have. So let's change a bit, side of the story topic, and let's ask question. Perhaps Elham, you can go first, bringing the industry side. So what materials do you see a focus on within your industry? Because when I first heard about Hitachi Energy, for me it's more going along nuclear. I don't know too much about the company, so it would be very nice to see what are you doing with AM.
Yeah, it's really a really nice question, because we really have challenging to adapt our components in the company to change the traditional manufacturing system to additive manufacturing, because of it's obvious from its name, Hitachi Energy. So we are working in all renewable energy system, power grid system. Our main focus is in copper materials, in pure copper. But as you know, for power grid system is like a wiring system and electricity, and it's really hard to adapt these kind of components to additive manufacturing that is used to print almost solid components. And also beside copper, we have aluminum and steel alloys that have really good, these are really good, except the fact that we have complex shape, and so we should use powder bed fusion system, and the size of our components is large. So we have this challenge about the size. And also beside this metal, we have insulating material like ceramics, aluminum oxide, for example, that they have high resistivity, electrical resistivity, and also some kind of polymers with high resistivity too. But my focus, actually, according to my expertise, is metal based.
Great. Candice, you maybe can go next?
Yeah, so I guess anyone who's done any polymer laser sintering will be aware of this. Most of the materials we have for polymer laser sintering are nylon 12. It's got really nice thermal and chemical characteristics that just make it work really well in the process. So we've tended to traditionally see we've got nylon 12, then we've got some other grades of nylon 12, maybe a bit more recyclable, a bit, less thermal degradation. Then we moved on to nylon 12 with some other bits in it. So, stick something in to make it more electrically conductive or stiffer or whatever. So we've been kind of hampered, I think, with that for quite a long time. We're starting to see more materials come through. Polypropylene's been a really popular one for, consumer goods, those type of areas. Where I'm really interested in at the moment is what we can do to add functionality to that kind of base polymer. So, let's say we take a nylon 12 part, we know the processes can produce these incredibly intricate, really, complicated geometries, but can we get them to do something more? So we've got some work going on looking at introducing antibacterial functionality into the parts. So saying you've got the part, it works as the thing it's meant to do, and also it has this extra layer of protection. So I'm really keen to kind of expand that and see us taking these parts, making use of those really good properties of the base polymer, and then saying, what else can we make it do? So can we make it do something more? Can we make those parts work a bit harder and kind of get this added value through the extra functionality as well as the geometric complexity?
Yeah, I think even there, but there is. I mean, with the new materials, you can decide whether you want to add new functionalities just by having a new material, where there, maybe you can just add, new materials and fuse them together and so on and so forth. But before we move forward, Elizabeth, please, give your answers as well.
I think for us, working sort of with just the FDM style printing, a lot of high sort of engineering type materials are what is kind of coming through, but we also have we're trying to have quite a high focus on like recycled PLA. So looking at I don't want to call it home recycling, but sort of recycling at the site that where you are printing as well. So with large scale, there's obviously much bigger parts, and if that goes wrong, you've got a lot more waste to deal with. So we do want to try and work on those recycled materials, and hopefully at some point in the future you can kind of bring that cycle back round, so you can print your part, and with the the smart printer, hopefully there won't be any waste, but if there is any, you can then kind of chip that down. It is a thermoplastic, you can remelt it and go again with that. So it's kind of looking at how the properties of recycled materials change from like your, I don't want to say pure PLA because there's never anything such as pure PLA, but kind of like how those properties change if you kind of melt down and try and reuse parts that have already been printed. So that has been a little bit of our focus. And I think going forward as well, with so much in the media about plastic waste and things, I think that's going to start to be a bigger focus going forward as well.
Absolutely, yeah. I mean, it's plastic, but I'm sure Elham, maybe with the with the metals, there is a lot of waste there as well. And something that has been now it's been a few minutes that we've been speaking. Something recurring that you have brought up is Elizabeth, you mentioning printing large scale, hence a lot of waste. Candice, you just said that you're trying to print with antimicrobial properties, and then I'm thinking, for instance, if you have an object that wants to that has antimicrobial properties, and perhaps you use it, I guess, for the medical sector, you probably don't want to just to throw it away after you use it. So there is a part of reusing the materials as well as the sustainability component, that it's basically that it's pressing out there. So maybe how do you think that sustainability can play a part when developing new materials? Where how would you go about embedding sustainability in new materials developing? Would you do it at the beginning, really on the material choice? Would you think more, because basically you have the freedom of design, so you design for sustainability, or maybe it's the manufacturing process that needs to be more sustainable? What do you think is where can AM play a part in that? I guess it's it's a complex question, but whoever feels to go for it. I think Candice, you have your mic on, so perhaps, yeah.
Yeah, I was going to say, I mean, the simple answer is probably all of those stages you've mentioned are really important. What I think in terms of looking at the materials is we really need to be looking at it from the production all the way through to the end of life. So I have a colleague, Ipshita, who's doing some excellent work looking at making polymers using bacterial fermentation, but taking waste products from other areas, turning them into the polymers. And then if you're looking at kind of novel processes like that and saying, okay, how do we make these polymers that will work really well in the process? Because that's crucial, right? They have to work well. They can't just be second-rate materials because they're sustainable. So I think looking at those ways of making the materials, and then it's also following that through and saying at the end, because every product has an end of life, nothing stays on infinitely. So really, and I don't think we've done a lot of work at this end yet, but I think we really need to, is if I have this part that has reached the end of its life, what can I do with it that's useful? And it might be turning it back into raw materials for the processes. It might be saying, actually, this material, if we kind of ground it down or we put it somewhere, would be really useful for this other industry. So it's perhaps looking cross industry as well and saying, we've got these bits of stuff in a certain form. Is there somewhere else that could be using that? But I think that requires us all to be talking to each other across the different sectors. And, are the polymer parts that reach the end of their life from our processes somehow of use to Hitachi and some of their processes? I mean, we don't know. So I think that's where we'll get some really interesting things on the sustainability side.
Yeah, I completely agree with sort of everything Candice said there. That it's the whole process, right, from making the materials all the way through. And to add to that as well, I guess this is my experience with a lot of students, but also designing appropriately for the part that you're making, not just going, oh, but it's 3D printing, so you can print anything, right? And then putting in kilos of support material that are just going to be wasted when a few changes to the design could actually remove the need for support material altogether. So yeah, it's not just students, it's a lot of other people as well. But people seem to think 3D printing's this magic process. And in a way it is, but that you can just make anything, any design when you haven't really thought about actually designing for 3D printing. It's just they see it as a magic manufacturing method to make designs that they haven't thought about how they've been made.
You're mute, yeah.
Yes, sorry. Candice and Elizabeth say something about their thoughtful comments about a polymer. I want to share my experience about metal in sustainability. Of course, when we working with additive manufacturing in comparison with, for example, traditional manufacturing system like CNC machining, we claim that this new process is really environmentally friendly because we remove using liquid lubricant, for example, that is really harmful to the environment, and also we reduce the waste of material. But again, now we have powder-based additive manufacturing system that you should cover all the substrate with metal powder, and after that they are affected from a high power source like laser or electron beam, and after that you couldn't use it again, and is really hard to recycle this metal powder. Is really challenging because if we want to be really sustainable with additive manufacturing, we should think about these wasting metal powders too. My focus to use filament-based additive manufacturing for metal, one of my focuses was this reason, because in that situation you don't have waste of powders. You have filament, you use it according to your design. And also, if you can have develop a new material that need a low energy system, for example, for some of the additive manufacturing system, we have a high power source of energy, like laser, electron beam. They are really harmful and they're affected the metal powder. They're really harmful for environment. But when we can develop new material with needing a low energy system, going down to below the melting point of the material, so you can have less footprint in the environment, and it's really awesome.
Yeah, absolutely. We have a question on the Q&A, which somebody asks, how do you expect spools that supply polymer filaments to change to become more sustainable? I believe maybe Elizabeth, since this is probably FDM related, maybe you can give an answer on that. And then just to make everybody aware, I think we have only 2 minutes left, so maybe make it short, so then we can at least say a concluding remark. Yeah,
that's a really good question, because we have piles and piles and piles of plastic filament spools that we can't seem to find anything to do with. Manufacturers don't want them back, even though I'm like, but if you get them back, then you could just reuse them. Doesn't seem to be a thing. Some manufacturers are moving to cardboard spools, which is good because they can obviously be more easily recycled. There was a really good initiative a little while ago, but it hasn't taken off yet, to kind of create a I can't remember what it's called, like a universal spool, which you could just buy your filament like as a spooled up but not on a spool, and then you would put it onto this like clip together spool, so you could just reuse it for like all your filaments. I thought that was a good idea, but it kind of, you need all the manufacturers to buy into it because everybody's got a slightly different spool size or a slightly different shape to their spool. So yeah, I think it's a really good question. I think there's an awful lot that could be done with that. If anybody's got ideas of anything we can do with all these empty spools, please do let me know. And yeah, just to sort of finish up, thank you everyone for really good discussion. I've really enjoyed it today.
Yeah, amazing. I mean, you know, if I can just say something concluding here is, you know, what we can summarize about today is absolutely we need to educate more the people, collaborate more, you know, and this is, I think it's always like that, you know, there's always room for improvement and collaborations. And then a lot as well has been said on, you know, how basically software and modeling could really help us, you know, even on the sustainability side, you know, doing these LCAs, you know, could to probably inform us better for future decisions. So thank you very much to all of you and to all the participants, you know, that were listening to us. And yeah, looking forward to the rest of the conference. And again, thank you so much to all of you.